Every winter, millions of people spend fortunes chasing warmth. The furnace roars, your energy meter spins, and still one room freezes while another swelters. It's a ritual of frustration that has haunted households for centuries. But what if I told you that civilizations from Siberia to Korea, from Sweden to Iceland, solved this exact problem with systems that made modern heating look like child's play? And no, you don't need electricity, oil or Wi-Fi to make it work. Stay with me, because what you're about to learn could change how you heat your home. And yes, make sure you subscribe, because the past knows secrets the future hasn't caught up with yet. In the frozen expanse of Siberia, where winter temperatures plunge to minus 40 degrees Celsius, families thrived in homes heated by a single massive structure, the Russian brick stove, or petka. This wasn't a stove as we know it. It was a thermal giant, weighing up to 2 tons and dominating the centre of the home. Its size was no accident. Every inch of brick acted as a battery, storing heat like a sponge. Inside lay a labyrinth of channels that forced smoke and hot gases to snake back and forth before escaping the chimney. This maze allowed the dense brick to absorb and store extraordinary amounts of thermal energy. Fire brick holds 80% more heat than iron, yet releases it 45 times slower. 2 short fires a day, each lasting just a few hours, could radiate gentle warmth throughout the home for 10 to 12 hours. The flat top became a sleeping platform where the elderly and children rested in dry, radiant heat, a combination of comfort and survival engineering. While the Russians mastered brute force, the Swedes refined precision. In 1767, facing rampant deforestation, Sweden demanded a stove that used less wood without sacrificing heat. Enter the tiled stove, a masterpiece of thermal calculation. Multiple internal flues force smoke through precisely measured channels, extracting almost every bit of energy. A gap between the inner core and outer tiles allowed the stove to expand without cracking, moderating the heat release and delivering a gentle 24-hour warmth. Surface temperatures stayed between 40 and 50 degrees Celsius, perfect for comfort and safety. With efficiency rates hitting up to 98%, these stoves could heat an entire home with the wood of just 1 tree per year. This was thermal mass engineering elevated to art, warmth that endured, elegantly and sustainably. On the Korean peninsula, a system called Ondol has been warming homes for over 2,000 years, not as a museum relic, but as living technology still in use today. Hot smoke from the kitchen's fire travelled through horizontal stone channels beneath the floors. Thick stones absorbed heat and radiated it slowly, turning the entire floor into a radiant heating surface. Temperatures remained around 27 to 32 degrees Celsius, while a single cooking fire heated the home for hours. Modern studies confirm Ondol's efficiency. Just 1 fire suffices to heat a space that would otherwise require a full furnace. Every calorie spent cooking doubled as home heating, turning a simple hearth into a dual-purpose survival tool. The floor itself became the social hub, where families ate, worked, and slept. Heat that shaped an entire way of life. In northern China, families developed a multifunctional heating system that doubled as furniture, bed, and social centre. The Kang was a raised hollow platform built from brick or clay, connected to the kitchen stove. Hot smoke travelled through the Kang's interior, heating it over a couple of hours, then radiating warmth for 10 to 12 hours. This wasn't just about comfort. Every piece of firewood worked twice as hard, preheating dinner and family beds in one sweep. Social life thrived around the Kang, with the family sharing warmth during meals, crafts, and sleep. The Chinese understood efficiency and human behaviour, creating a system that extracted maximum value from minimal resources. Icelandic settlers discovered the ultimate heating hack. Let the earth do the work. Sitting on volcanic hotspots, they tapped natural geothermal energy to heat homes, workshops, and even churches. Wooden pipes and stone channels carried water from hot springs, delivering warmth 24 hours a day without burning a single tree. By the 13th century, this system had become sophisticated infrastructure. Modern upgrades only improve pipes and pumps, but, the principle remains unchanged. Icelanders learned something profound. The most efficient heat is free heat. For 7 centuries, this approach has provided comfort, sustainability, and energy independence. Across cultures, from Japan's kotatsu to Iran's korsi, Afghanistan's sandali, and Spain's brasero, families discovered zone heating centuries before it became a smart home trend. These low tables held a heat source beneath, covered with thick blankets to trap warmth. Legs and lower bodies stayed cosy while the room stayed cool. A small charcoal load could keep 4 to 6 people comfortable for hours, reducing energy waste by an order of magnitude compared to heating entire houses. These tables weren't just practical. They were social magnets, drawing families together around warmth, meals and conversation. Efficiency and social cohesion all in one design. So why did we trade these marvels for forced air and electric heaters? The reasons are actually pretty revealing. Ancient systems required labour, skill and careful attention, luxuries we could no longer afford as societies industrialised. Safety was a concern. Carbon monoxide and house fires were real threats. And with coal, oil, gas and electricity promising convenience, we chose ease over efficiency. We sacrificed sustainability, resilience and deep comfort for instant warmth. Modern systems work, yes, but we often heat empty rooms, blow dry air across our faces, and spend more energy to achieve less comfort. Ancient people understood their systems intimately. Today, most homeowners couldn't really explain how their furnace works. When you study these systems, one thing becomes clear. The past often got it right. Thermal mass beats quick burning. Radiant heat feels better than forced air. Heating people directly outperforms heating empty space. Free energy, well, it beats purchased energy every time. These forgotten heating systems, Petka, tiled stoves, Ondol, Kang, geothermal networks, heated tables, show that, ingenuity, patience and observation can beat speed and convenience every time. They provide lessons not just in warmth, but in resilience, sustainability and comfort that, honestly, reaches bone deep. Modern technology has given us automation and convenience, but in doing so we lost something essential: understanding. Ancient engineers knew the physics behind their creations, and they built systems that lasted for centuries. There is wisdom here worth reclaiming. If you want to feel real warmth, save energy and explore solutions that have withstood the test of time, it pays to look back. The next time winter bites, remember, your ancestors weren't cold. They were brilliant, and you can be too. For more deep dives into forgotten technologies and historical survival secrets, subscribe to The Forgotten Warfronts, and hey, share this knowledge with anyone who still believes modern tech has all the answers. History holds more warmth than you think.